In the last few examples, we were finding the average rate of change, looking at a graph of a function. Now we want to do the same thing without looking at a graph, but instead using the given function to find the corresponding y values. In example 5, we have our function f of x. We're given values for x1 and x2, the two endpoints of that interval that we want to consider. Then to find those corresponding y values, we'll substitute in x1 and x2 into our function, meaning we'll substitute in to find f of 1.3 and to find f of 2.6. Keeping in mind, function notation means we replace every instance of x with this value 1.3. That will give us negative 1.3 squared plus 16, or 14.31. Similarly, as we evaluate f of 2.6, we'll substitute in 2.6 for every instance of x to get 9.24. These are our y2, well, let's make sure I stay consistent with my notation here. This should be y1, and this is our y2 value. Rather than reading those from the graph, we plug our x values into the function to generate those values, and then we plug our two coordinate pairs into the slope formula. If we take 14.31 minus 9.24 in the numerator, then we need to take 1.3 minus 2.6 in the denominator to get a result of negative 3.9. In this case, we can see from our result that our average rate of change is negative, less than 0. So over this interval, our function is decreasing on average. In example 6, we'll take the same approach. We'll find f of our x1 value, which is 2, and we'll find f of our x2 value, which is 5. Let me change that. This is actually a function g in this case, so we want to make sure we're referencing the right function name. We'll evaluate g of 2 and g of 5, which means we'll take that given function, substitute in the value provided to us. So we're finding the opposite of the square root of 2 plus 4, which comes out to be approximately 2.58579. Similarly, g of 5 will come out to be about 1.76393. And then to find the average rate of change, we find the slope between those 2 points. So we'll take 2.58579 minus 1.76393 and divide that by the corresponding x values, 2 minus 5, to get a result of approximately negative 0.274. So whether we're coming up with the average rate of change from a graph or from the function, we start off by identifying the given x1 and x2 values, find the corresponding y1 and y2 values, and then evaluate the slope formula to find the slope of a line passing between those 2 points.